Okay, this next lesson is a second lesson on solving trig equations in radians. What we're going to go on to look at today is some more exam style questions, so slightly more tricky than the ones that you were doing in the previous lesson. Okay, so how it fits in with our sequence of lessons for this chapter 5 in the Year 13 Pure textbook is we've done introduction to radians, we looked at exact values, we spent a couple of lessons on arc length and area of sectors, and then we've done one lesson on solving trig equations in radians. If you remember, it's very similar to what you've done in degrees. The only thing is that you need to then use your cast diagram and have your calculator in radians. Okay, so we're going to have a look at a few exam style questions. Okay, so here's our question number 1. Okay, so you want to pause the video here and just write that one down. Okay, so whenever you're looking at an exam question, have a look at how many marks it's worth, how it's broken down. The first part is a show that. Whenever you have a show that, do make sure that if you don't manage to successfully do that, do go on and use that in part B, because you can see the number of marks. The show that is actually only 2 marks, solving it is 6 marks. Okay, so it's going to be important that you go on and solve it even if you're not successful with part A. Okay, now we've done questions like this in our previous lesson. I'm just going to write it up here to make sure I've got enough room for part B. Now you can see we've got a quadratic with a sine squared and a cos in it. We need to make sure that we have a cos and a cos squared. So what I'm going to do is I'm going to replace my sine squared with 1 minus cos squared. Okay, plus 9 cos x minus 6 equals 0. It is a show that, so do be nice and clear showing you're working. Expand out my brackets. Okay. And then what you'll see is the final answer that they want to show. They've taken everything over onto the other side, so that becomes a plus 4 cos squared x. That plus 9 becomes a minus 9 cos x. 4 minus 6 is minus 2, so when it goes on the other side, you get a plus 2 equals 0. So that's your 2 marks. There's really kind of 1 mark for putting in your 1 minus cos squared, and then 1 mark for successfully rearranging it. Okay. So, solving trig equations, always have a look, are we working in radians or are we working in degrees? You know we're in radians because that's what this chapter is all about, but in an exam you might have a mixture. Okay, so because you're solving for x between 0 and 4 pi, that tells you that you are working in radians. Okay, the other thing to say, the word hence means you must use what you've done in the previous part of the question. Sometimes there are alternative ways of solving things, hence means you must use what you've used in the first part of the question. So the first thing I'm going to write down, okay, is that equation is exactly equivalent to the one that I rewrote in part A. So we know from part A that the equation is equivalent to solving that. Okay. Now, when you've got the quadratics, the majority of the time they will factorise. Okay, so if you're not particularly good at factorising where you've got a number in front of the squared thing, put it in your calculator, find out the answers, and then write the corresponding brackets to give you those answers. Okay, hopefully your calculator will have told you it's the answers are 2 1/4, so that gives you those 2 brackets. Okay, so let's have a look at our answers then. This first bracket here gives us cos x equals 1/4. So in a moment, we're going to work out the answers for that. This second bracket gives us cos x equals 2. You remember from last lesson, we sometimes get answers that are not relevant. Cos x only goes between +1 and -1. So what I normally do is put a line through it like that and just say ignore, okay, because there are no values where cos x equals 2. So this is the one we've got to solve, cos x equals 1/4. So you know what we do is we use our arc cos, or our cos to the -1 is the button on our calculator. We use that to get our initial value. Okay, so pop that in your calculator. Now, I know the question says to 1 decimal place, but we're going to need to find some other answers as well. So when I write it down, I would leave it as a few decimal places just to make sure I don't round it too much. Okay, so that is one answer. Okay, well, it would be 1.3 to 1 decimal place. We're going to now use our cast diagram, okay, to get another answer. C, A, S, T. Here is my angle, my 1.318. Okay, so what we're looking for is we're looking for which other quadrant is cos positive, because remember you're doing arc cos of plus 1/4. So the other quadrant is that one. Remember that angle there is the same size as that angle there. So the second answer we're going to get, we read, remember from our last lesson, we read this all the way around like that because the values we're looking for are all positive. So between 0 and 4 pi, we'll have a look at that in a minute. Okay, so my second answer I'm going to get by doing 2 pi minus 1.318. Okay, keep that as your answer in your calculator, do 2 pi minus answer, and you get 4.965. Okay, so if the question was only between 0 and 2 pi, that would be our two answers. Now, the question is between 0 and 4 pi, so that means we get another two answers. So we're expecting to get 4 answers. How do we get those other answers? Well, all we need to do is we need to take our answers that we've got here and we add 2 pi to them. If you think about why that works on your cast diagram, let's just choose a green one. You're going from here, okay, you're going to go all the way round and then back to there again. So what you're going to do is you're going to do a full turn, okay, plus that bit, all right, so that's going to give you another answer. Okay, so what we do to get our next answer, let's just get back to blue, is I'm going to add 2 pi to each of my answers to give me some additional answers. So 1.318 plus 2 pi, okay, that gives me 7.601. And okay, 4.965 plus 2 pi. Remember, when you put plus 2 pi, use the pi button in your calculator, and that gives me 11.248. Okay, these are my answers. Let's just go back to my question, double check the accuracy. 1 decimal place. If you don't state them to 1 decimal place, okay, then you will lose some marks. So here's my answers. X equals 1 decimal place, 1.3, little circle or rad. Okay, next one, 1 decimal place, that's going to be 5.0, round carefully. Next one, 7.6 to 1 decimal place. And the next one, the final one, 11.2 to 1 decimal place. Now remember, you can check these by putting them back in your original equation and making sure that they work. Remember, when you put them back in, you won't get exactly 0 because we have rounded them, but you should get roughly 0. Okay, so do take a little bit of time to do that because that will pick up any mistakes you've made. So that's a good 6 marks, that question. Okay, let's have a look at the next one then. Again, pause the video just to write down your question. Very similar format to the other one. Okay, we've got to show that, and then we've got a hence solve, slightly different range of values, but it is between 0 and pi, so that's telling us it's radians. So again, if you can't manage to show that, if you're not too sure how to do the show that, make sure you then go on and solve it, because the hence means using that from the first part. Now, because it's a show that, that's a little bit of a hint. You can see in the show that there's nothing to do with tan in there. Okay, it's only got sines and coses in. So the first thing you're going to do then is take the tan that's in the original question and you're going to write that. Remember, that's your other identity. You're going to write that as sine over cos. Do be careful, because it's tan 2x, it's sine 2x over cos 2x. Now, keeping half an eye on the thing we're trying to show. Okay, you can see it doesn't have any fractions in. So what we're going to need to do is multiply through by cos 2x. I'm being really clear as to the steps I'm doing, just to make sure, because it's a show that the examiner can see that I know what I'm doing. So multiply by that, I get sine 2x equals 5 sine 2x cos 2x. And then if we look at the thing we're trying to prove, they've taken it all over on one side and factorised out the sine 2x. Okay, so I'm going to just show that in a couple of steps because it is a show that minus 5 sine 2x cos 2x equals 0. I've collected it on the right side, take out my sine 2x, and what do I get in my bracket? 1 minus 5 cos 2x. Okay, so that's the 2 marks. Right, part B, hence. Remember, hence. So what that means is using what we've got here. Here's already something that's factorised. 2 things multiplied together to give 0. So I get answers if either of those are 0. So the first bit I get is sine 2x is 0. Okay, so I'll look at answers for that in a minute. Second one, cos 2x. Okay, 1 minus 5 cos 2x is 0. So that gives you cos 2x is 1 over 5. Okay, now my range of values that I was given in my question is x between 0 and pi. These are 2x here, okay, so I need to get values for 2x between 0 and 2 pi. All right, so I'm going to solve them in the same way as I would if I have a 2 pi range, because I'm solving between that and 2 pi. Now, when you get sine 2x equals 0, it's a lot easier to think about what the graph looks like than to use a cast diagram. Okay, values that give you 0 are 0. If you think about how the graph goes, pi and 2 pi. Okay, so I've got those 3 values. That's where the sine graph goes through the x-axis. If you're not sure, use your calculator to help you. So when I divide those by 2, I get 0. I get pi by 2, and I get pi, all of which are within my range of values 0 to pi. Okay, let's do the second one here. Okay, so do my arc cos. So 2x equals arc cos 1 over 5. Pop that in your calculator. Leave a few decimal places, 1.369. Okay. So I'll divide that by 2 in a minute to get my final answers. But remember, this was the important thing from the last lesson. We use our cast diagram now to get another value before we divide by 2. Okay. So here's my first value for 2x there, 1.369. Where else, again, it's another cos. Where else is cos positive here? So when I read that value off, I'm going all the way around like that. Okay, so that answer is going to be 2x equals 2 pi minus 1.369. Okay, and that gives me 4.9137. Okay, so to get my final answers here, what I'm going to need to do is take those 2 values and divide them by 2. So x equals, let's go back to the question, 1 decimal place where appropriate. So that tells you that these are fine left like that because they're in terms of pi, but where appropriate, I'm going to round these to 1 decimal place. So I'm going to half 1.369 and then round it to 1 decimal place. That gives me 0.7 radians, put my angle measure on, and I'm going to take 4.9137 and divide it by 2 and round to 1 decimal place. So that's going to give me my answers there. Again, remember, you can take those and you can pop them back into your original equation and you can make sure they work. That will highlight any mistakes that you've made on there. Okay, that was number 2. 1 then. All right, so this is a 10-mark question. So there's quite a lot going on there. First bit is sketching a graph. Second bit is finding where the graph meets the coordinate axes. Okay, and then the third part there is solving an equation, which is the majority of the marks down there. Okay, right, so let's sketch my graph first. Have a look at my graph. Make sure you've got the question written down. So this is going to be like the cos x graph, okay, but because you've replaced x by x plus pi by 6, that's going to be the cos x graph translated, okay, by, remember when you replace x by x plus something, it moves it the opposite way to what you think. So it's translated by minus pi by 6 in the x direction. Okay, so if I think about my original cos graph, I probably would just think about this in my head, but if you do need to draw it, the original cos graph, remember, goes through at 1 and then it repeats like that. Okay. Now, make sure when you're asked to sketch a graph, you only sketch it within the range of values that it is asked for. So it's asked for between 0 and 2 pi. Okay, so on my original graph, when we look at our 0 and 2 pi, that would go from here is 0, and that would be repeating up to there 2 pi. So when I've shifted it to the left by minus pi by 6, okay, it means it's going to start on the y-axis a bit further along this curve bit here, and this peak here, okay, is going to turn and go over the other side a little bit. Okay, so when I'm drawing it, I'm just going to draw it here to make sure I've got enough room for the rest of my question. I'm just drawing it between 0 and 2 pi. Here, it's already starting to go down. Okay, so it goes down like that. So it's starting to go down. Okay, it goes up like that, and then it just goes just past the curve because of the translation. Okay, so this bit here is going to be 2 pi. All right, but this bit actually, let's just make that a little bit clearer there. I'll just rub that a little bit out because I don't think that was particularly good enough there. So I'm just going to draw that little bit in because the curve will actually peak about here. All right, so the curve will go like that. Oh. Right, I'm going to carry on with this. I just mucked my graph up there. Okay, so let's go back to drawing that graph again. So I'm just going to draw it between 0 and 2 pi. Okay, and it basically starts past the curve, past the curves there. So it goes down like that, up like that, and then it just goes just a little bit past that. So the important thing I think for you to make sure, which I failed to do the first time I tried it, is to make sure that you see that this curve bit here, that's sort of been translated that way a little bit. All right, so something that looks like that is always quite difficult to draw, especially on the drawing tablet. So cover between 0 and pi. Right, so part B says write down the exact coordinates of where the graph meets the axes. All right, so let's do the y-axis first. The y-axis, so meets the y-axis. Remember, x is 0. So we're going to be doing y equals cos of pi by 6. Pop that in your calculator. That's one of my standard, and I get √3/2. So it does ask for coordinates. So make sure you write that as 0 √3/2. Okay, where does it meet the x-axis? That's where y is 0. So we're solving cos x plus pi by 6. Sorry, that's a little bit untidy there. We're solving y equals cos x plus pi by 6 equals 0. Okay, so x plus pi by 6 equals, if we think about where the cos graph is 0, all right, the original cos graph, it is 0 at pi by 2 and it is 0 at 3 pi by 2. So to get my coordinates of my translated graph, I'm going to subtract pi by 6 from each of those. So that's going to give me my two answers. use your calculator if you're not very good with fractions. That's pi by 2 minus pi by 6. And this is 3 pi by 2 minus pi by 6. Okay, so that's my answers for those ones. Lovely. On to the bit which is the majority of the marks for this question. Solve. Range of values 0 to pi. So we're working in radians. Okay, and it says give your answers to 2 decimal places. So the thing I'm solving, all right, is I'm solving cos x plus pi by 6 equals 0.65. So if I do my arc cos, I'm going to get x plus pi by 6 equals arc cos of 0.65. Make sure your calculator is in radians, and that gives me 0.863. I'll keep that as an exact value. Class diagram again. We've done quite a lot of coses, haven't we? We know that cos is positive there. We also know that cos is positive there. So I'm going to get my second answer by doing that, which is 2 pi minus that. So I'm going to do that, remember, before I muck about with the minus pi by 6 bit. So my second one is going to be 2 pi minus 0.863, which is 5.420. Okay, so how do I get my final answers? What I do is I take my original 2 values. So I've got 0.863 and I do minus pi by 6 because that is equal to x plus pi by 6. And that gives me I'm going to round at this point in time, 0.34 radians. Okay, 2 decimal places. And then my second answer is 5.420. Again, I've got to take away pi by 6. Okay, and that gives me 4.90 radians. And you can put those back into your calculator and do cos of that plus pi by 6 and just make sure you roughly get 0.65. And if you do, you know you're fine. Okay, right, it's over to you now then. So you've got 5 questions from exercise 5e. These are exam questions, so work through those carefully and accurately, showing all of your solutions clearly. Okay, make sure you get all of these solutions within the range that they specify. They might vary between questions. Make sure you're in radians, show clear working. Okay, I don't want any of those submitted, but I will go through those when I next speak to you on Teams. What I do want submitted is this one here. Homework assignment 2 is basically the next homework assignment, and that is all about solving trig equations. So it's not lots of questions, but it is some questions, some exam style questions on solving trig equations. So I'd like that submitted, please, by the end of Thursday, so I can get that marked on Friday. Okay, right. Thank you very much.